Students, good morning. I am so happy to see you once again through this CETEL YouTube channel. My today's class is Steady State Molecular Diffusion in Liquids. Already in my previous videos, we developed the expression for flux of molecular diffusion in gases. Today's class, Steady State Molecular Diffusion in Liquids. The fundamental equation, that means fixed first law of diffusion, is JA is equal to minus DAB into dou CA divided by dou Z. This is fixed first law of diffusion. Flux JA is relative to average molar velocity of the compounds present in the solution. DAB, diffusivity or diffusion coefficient. It is a measure of diffusive mobility of a component in a solution in B. Dou CA by dou Z, changes in concentration with respect to distance. This is called as concentration gradient. The minus sign indicates decrease in concentration. Clear? Right. Next, the total flux N is equal to NA plus NB, where NA and NB, they are made up of two parts. For NA, this is total flux into XA and JA. We already discussed lot, hence I am straight away going to write the equation. So NA is equal to NA plus NB into XA minus of DAB into dou CA divided by dou Z. This is the base equation to derive the flux of a compound in fluids at rest and in laminar flow. Thereafter, we integrate to find the changes in concentration with respect to distance, and we arrive the equation like this. NA is equal to NA divided by NA plus NB into DAB into C divided by Z into ln NA divided by NA plus NB minus Ca2 divided by C. Similarly, NA divided by NA plus NB minus Ca1 divided by C. In my previous videos, molecular diffusion in gases, we assume that DAB is constant. Similarly, concentration C is also constant. Both are constant in case of gases. But for liquids, this is not a satisfactory. It will not provide a accurate value. It causes a serious error. In case of liquids, we have to go for best average of DAB. Best average of DAB. Similarly, best average concentration C. Both are should be average. Clear? Right. Concentration is nothing but moles per liter. The unit of concentration is moles per liter. Hence, this term should be replaced by density divided by molecular weight. Density is solution density, and M stands for molecular weight of the component. Molecular weight of the component. What is the unit for density? Density is nothing but kg per meter cube. And what is the unit for molecular weight? Kg per kg mole. Kg gets cancelled. The remaining thing is kg per meter cube. Sorry, k moles per meter cube. Moles divided by volume of solution liter. Again, same unit concentration. Hence, I am going to replace C by rho divided by M. It should be an average value. Clear? So this equation becomes for liquids, Na is equal to Na divided by Na plus Nb into DAB divided by Z in terms of C, density divided by molecular weight, average. Clear? Next, ln Na divided by Na plus Nb minus Ca2 divided by C and Na divided by Na plus Nb minus Ca1 divided by C. This is the expression to estimate flux of a component in liquids. Flux of a component in liquids. This is individual concentration divided by total concentration. That is called as XA2. Similarly, Ca1 divided by C is equal to XA1. Now we are going to establish relationship between Na and Nb. We have two cases. Case 1. That means diffusion of A through non-diffusing B. Diffusion of A through non-diffusing B. Already we discussed a lot. For this case, Na is constant. And Nb is equal to 0. Hence, for this case, Na divided by Na plus Nb is equal to 1. Substitute this relationship in the main equation. Na is equal to dAb divided by Z into rho by M average into ln 1 minus Ca2 divided by C. That means Xa2. 1 minus Xa2 divided by 1 minus Xa1. As discussed in the previous case, Xa1 plus Xb1 is equal to 1. Similarly, Xa2 plus Xb2 is equal to 1. I am in need of Xb1 as well as Xb2. So in this case, Xb1 is equal to 1 minus Xa1. Instead of 1 minus Xa1, I am going to substitute Xb1. Similarly, Xb2 is equal to 1 minus Xa2. Instead of 1 minus Xa2, I am going to substitute Xb2. Clear? I am going to rearrange this equation. Xa1 plus Xb1 is equal to Xa2 plus Xb2. So Xa1 minus Xa2 is equal to Xb2 minus Xb1. Both are same. So just small modification for simplification of this equation. Na is equal to dAb divided by Z into rho by M average as before in the gases Xa1 minus Xa2 whole divided by Xa1 minus Xa2. Multiplication and division of Xa1 minus Xa2. There is no changes in value. The term added to simplify the expression. What next? Ln Xb2 divided by Xb1. Instead of 1 minus Xa2, I am substituting Xb2. Instead of 1 minus Xa1, I am substituting Xb1. Hence this equation becomes dAb divided by Z rho by M. Here Xa1 minus Xa2. Instead of Xa1 minus Xa2, I am going to substitute Xb2 minus Xb1. Xb2 minus Xb1. This is in numerator. It should become the denominator. Ln Xb2 divided by Xb1. Hence, this equation becomes dAb divided by Z into mean value of B into rho divided by M average into Xa1 minus Xa2. This is the expression for estimation of flux for diffusion of A through non-diffusing B in liquids. Clear? Right. Where Xb mean is equal to Xb2 minus Xb1 divided by ln Xb2 divided by Xb1. Clear? Case 2. Equal mode of counter diffusion. equal molar counter diffusion. Case 2. Equal molar counter diffusion of components in liquids. In this case, Na is equal to minus of Nb. While substituting this relationship in this equation becomes indeterminate. Hence, we have to go for the base equation, that is Na is equal to Na plus Nb into Xa minus of dAb into dou Cap dou Z. Substituting Na is equal to minus Nb, this term becomes 0. The final term Na is equal to minus of dAb into dou Ca divided by dou Z. I am going to integrate this equation in order to find changes in concentration with respect to distance. I am going to integrate this equation in order to find the changes in concentration with respect to distance. Hence, this equation can be rewritten like this. dZ is equal to minus dAb divided by Na into dCa. Limit tends to Ca1 to Ca2. Limit tends to Z1 to Z2. Z2 to Z1 is called as Z. That means minus of dAb divided by Na into Ca2 minus Ca1. Clear? The minus sign can be removed. Z is equal to or Na is equal to dAb divided by Z into Ca1. Instead of Ca2 minus Ca1, I am going to write Ca1 minus Ca2. Clear? Next, dAb divided by Z into C divided by C into Ca1 minus Ca2. Clear? This C, dAb divided by Z. Instead of this C, I am going to write density divided by molecular weight average. This should be inside. Ca1 by C is equal to Xa1. Ca2 divided by C is equal to Xa2. This is the expression to estimate the flux for the case of equal molar counter diffusion of components in liquids. Thank you.